Alright, I'm starting with number 59. It's an exponential function. Now initially it looks like like it's going to be a growth, right? I'm sorry, a decay because it's 1 over 6. But then notice it has a negative up here, right? A negative x. So what I did is I went ahead and converted the negative x to positive x, and then we get this. So now you see it's actually a growth function. Here are the reference points, and there are no transformations. So all we have to do now is plot the 0, 1 and the 1, 6. And we know because k is 0 that the horizontal asymptote is y equals 0. So it's right here, and then we connect the points. And that's it for that one. Alright, so 60 you have the base is 4. The h is 1. It's right here. The k is negative 3, so that tells you that the horizontal asymptote is y equals negative 3. Okay, so we could go ahead and add it in right now. Okay, the h is 1, so that means that we're going to add 1 to all the x's. The k is negative 3, so we're going to subtract 3 from all the y's. Okay, so the new points become 0 plus 1, 1, 1 minus 3, negative 2, 1 plus 1 is 2, and 4 minus 3 is 1. So we're going to plot those points, 1, negative 2, right here, and 2, 1, right here. And so it's going to be something like this. Okay, to get the x-intercept, let me put it here on this side. We make the y 0, and then we solve for x. So that means we get 3, and then we change it to log form. Log base 4 of 3 equals x minus 1. We add 1 to both sides. So 1 plus log base 4 of 3 equals the x-intercept. Okay, so you just plug this into your calculator, and that'll give you this point right here that I'm pointing, that I'm marked as red. That'll give you that approximate value. For the y-intercept, you make the x 0, and you solve for y. So 4 to the 0 minus 1 minus 3, so that's 4 to the negative 1 minus 3, so that's 1/4, right, minus 3, so that's negative 2 3/4. So that would be right here. So it's actually a little bit lower, negative 2 3/4. So the curve would have been a little bit lower this way. Okay, and that's it for that one. Alright, so for this one the base is e, but notice that the exponent is negative, so that means that the x's are going to be multiplied by negative 1, so or just put negative x. The a value is 3, and the k value is 3, so it's going to be 3y plus 3. So 0, opposite of 0 is just 0. 3 times 1 is 3, plus 3 is 6. The opposite of 1 is negative 1. And then 3e plus 3. That would be your y value for that. Okay, so we go ahead and plot this. First thing, the horizontal asymptote, k is 3. So we put y equals 3. And then 0, 6. And negative 1, 3e plus 3. That's approximately equal to 11.1, but I don't think it's, let me see if it's going to fit 6, 7, 8, 9, 10, 11. So about here. Okay, and connect the points. And there it is. Now this one, the y-intercept is 0, 6. We already have it right here. The x-intercept does not exist. It's not going to cross the x-axis. Alright, for 68, all you're doing is changing the form from exponential to logarithmic. So here's the base, here's the exponent, and this would be the answer to the to this problem right here, to this power. So how you write it is log base 6, because that's your base, of 1 over 7,776 equals the exponent. Remember, on the other side of the log, that's always going to be your exponent. Okay, so for b, the base is e, so we're going to say natural log of 1.284 equals the exponent. On the other side of the log is the exponent, always. You're solving for x, so remember the property says that if the base of the logs is the same, then you equate the arguments. So 4x minus 6 equals 4, and then solve for x. So that's 4x, add 6 to both sides, that gives you 10. Divide by 4, that gives you x equals 10 over 4, which can be reduced to 5/2. So remember that logarithmic functions are inverses of exponentials, so that's why you see the reverse order right here. Okay? The a is 2, the h is 2, and the k is 0. There's nothing added here. So these don't have horizontal asymptotes, they have vertical asymptotes, and it's x equals h, so h is 2. And again, remember, we're talking about this one right here, that 2. So the x's are being increased by 2, and the y's are being doubled. That's this 2 right here. So 1 plus 2 is 3, 2 times 0 is 0, e plus 2, and then 2 times 1 is 2. So this would be about 4.7, okay, because e is 2.7 approximately. So we draw the vertical asymptote at x equals 2 right here, and then the 0.30, and 4.72, so about here. And then just connect the points, and you are done. Okay, so here's another logarithmic equation. So notice the order of the reference points right here. B is 5, the base. A is -1, and K is -5. Notice this is not H because there are no parentheses around the X and the 5. So this is actually H. So the X is not changed at all. So let me go ahead and, so the X stays the same. The Y, on the other hand, you're going to take the opposite and then -5. So that vertical asymptote is x equals 0, because h is 0. So let's go ahead and change the points. So 1, -5, 5, -6. So vertical asymptote is right on the y-axis, and then 1, -5, and 5, so 5, -6 here. So remember, the negative up here flips the graph over the x-axis. So that's why it's going to take on this shape right here. Like that. I mean, it should be getting close. I know I messed up because my graph looks like it's going away from the y-axis. It should be getting closer, closer, closer to the y-axis. So it's more like this kind of thing. Okay? And that would be the graph.